Let's look at 12.5, which is problem solving with normal distributions. So we're going to solve problems involving normal distributions. So let's review about the standard normal distribution. We have 0 is whenever you have your mean is right there in the middle. And then if you go above, that's 1 standard deviation above, 2 standard deviations, 3 standard deviations. And then -1, which is below the mean, -2, and -3. The rule of 68, 95, and 99.7 is between -1 and +1 is 68% of the data. Between -2 and +2 is 95% of the data. And then from -1 to, or -3 to +3 is 99.7% of the data. Well, what if we want to find half or -1.5? We've got to have a tool to use for that. So the tool that we have is this chart. It's a table, z-scores and percentiles. So you look for the z-score and then you get the percentile. So example 1 is finding the percentage of items in normal distribution. Use information shown below to fill in the blanks so that the resulting statement is true. The percentage of scores greater than z equals 2.6. So 2.6 is right here. So we want greater than though. So I'm going to shade this. This is what we want the percentage of. So in order to find out what this is, we've got to find out what below is. So below 2.6 is this amount, 99.53%. That's what our table gives us. It gives us the area under the curve below that z-score, or less than that z-score. So if we want to find above, it says greater than that amount, we're going to have to subtract from 100% because all of the area under this curve, all the probability is all the data, which is 100%. So we're going to do 100 minus 99.53 to get the area above 2.6. If we subtract that, 0.47. And this actually came from here. So let's see, 2.6. I would look at the positive z-scores, 99.53. So 0 is your mean, which would be 50% of the data. And then your negative scores would be over here, okay? So it starts out really low, and then it'll go at 4. The z-score of 4 is 99.997, which is close to 100%. Okay, let's look at this. It says, use information shown below to fill in the blanks so the resulting statement is true. Percentage of scores between -1.6 and 2.6. So it's this percentage between the two. So the way you find this is you find out what the area below -1.6 is, the area below 2.6, and then you subtract them. So they've already given it to us, 5.48. And then from 2.6, that way, below 2.6 is 99.53. So to find just the area between, you would subtract them. (94.05%) between -1.6 and 2.6. And this is above 2.6. Okay, let's go to the next example. Find the percentage of data items between two given data items in a normal distribution. First thing you need to do is convert to a z-score, which is data item minus your mean divided by your standard deviation. Use the table to find the percentile corresponding to the z-score. and then subtract the lesser from the greater. So this is where we are finding the between. I like to draw a picture and label the z-scores. So this is between. We're going to do above and below first, though. And these already give us the z-score. So use the accompanying table of z-scores and percentiles to find the percentage of data in a normal distribution that lie below and above 0.55. So if you have your normal distribution, you know 0 is here, so 0.55 would be here. So we first want to find below. And that is actually what our table gives us. So below part A, 0.55 is, let's see, 0.55, it's right here, 70.88. So then to find part B, which is above 0.55, that's this area right here, that's part B. This is part A. So what we're going to do is we're going to do 100 minus the 70.88, which is 29.12%. By subtraction. Let's look at the next one. Use the accompanying table of z-scores and percentiles to find the percentage of data items in a normal distribution that lie below and above the z-score of negative 0.05. So if we draw, put your 0 there so that way you can orientate yourself. So the negative would be below. And so this would be the below area. And that's what we actually find on the table. So part A below negative 0.05. Let's look. And you look on the negative side. Right here. Negative 0.05, 48.01. So we'll write that down. And so that's part A. So then part B would be here, and that's the above. So we would need to subtract from 100. So 100 minus 48.01. .99% is above, which that would make sense because at 0 it's 50%. So it's a little bit more of an area than that. So it's a little bit more of the probability or percentage. Example 3, find the z-scores between. So that's where we're going to use this. But they have given us the z-score, so we don't have to convert. Okay, find percentage of data items in the normal distribution. So 0, 0.6, and 1.8 would be up here. So we want to find the area between. So the way you find that is you find first, what's the area below 0.6, which is from the table, below 1.8, and then you subtract them. So 0.6, 72.57, then below 1.8 is right here, 96.41, and then subtract the greater one from the smaller one. .84. So that is our solution between the two z-scores. Okay, let's find the other one. We're gonna find the z-scores that lie between. So let's do 0. So negative 2.5 would be here, and negative 0.4 would be here. So we want to find between them. So you have to find the corresponding percentages. So below negative 2.5, below negative 0.4, and then subtract them. So let's find the negative 2.5. It'd be 0.62. And then the other value right here, 34.46. And then to find between, we would subtract them. 34.46 minus 0.62. 33.84. And these should have percentages on them. Okay, so here's a summary of how you know if you are just giving the number, subtracting them from 100, or subtracting them from each other. So this says percentage of data items less than the given z-score. It just comes directly from the table. Percentage of items greater than the given z-score. You'll find what's on the table, subtract from 100, and add the percent sign. Percentage of items between two values. You find those you use those z-scores, use the table, and then subtract them from each other. So let's do some application problems. Go ahead and read that. So let's write down the important information. So the mean is 116. Standard deviation is 20. So we first need to find our z. So it says we want to find above 114. So if you look at our normal distribution, 116 is here, so 114 is here. And we want above. So we're going to find the percentage above. So in order to do this, we've got to find out what the z-score is. So we know it's going to be negative because this would be a 0 z-score. So anything below it's going to be negative. So the formula that we have is the data item minus the mean divided by standard deviation. So that'd be 114 minus 116 divided by 20. So you can put it in just like that, or you can do it one operation at a time. So negative 0.1. So that's what this is, negative 0.1. So we want to find above. So in order to find above, we got to find below. And that's what's on the table. Then we'll subtract from 100. Looks like it says 46.202. So that's what this area is, or this percentage. So in order to find above or greater than, or above, greater than 114, we would do 100 minus 46.02. 53.98%. Okay, the last example. Find the percentage of data items between two given data items. Go ahead and read through the problem. So this breaks it down step by step. So step 1, we need to convert to a z-score. So we know that the mean is 44.6, standard deviation is 14.4. So we are going to do the data item, 37.4 minus 44.6, and then divide by 14.4. So we know it's below, so it's going to be a negative z-score. And then the other one, 80.6, so that's above the mean, so it's going to be a positive z-score. So those are your two z-scores. So if you look at it like a normal distribution, we have 0, we have the positive 2.5 here, which is represented by 80.6 hours, and then the negative 0.5, which is here. We want to find between the two. So these are the converted z-scores, which standardize it. So we've got to find the percentage of below negative 0.5 and below 2.5. So step 2 says use the table to find the percentage corresponding to these z-scores. So let's look at negative 0.5. It's right there, 30.85. This means that 30.85% self-employed Americans work fewer than 37.4. Table shows a percentile corresponding to 2.5. Let's look at 2.5. Right here, 99.38. This means that 99.38% of self-employed Americans work fewer than 80.6. 80.6 is a lot. So most Americans, majority. So in order to find how many work between those two values, the 44.6 and, the 37.4 and the 80.6, we're going to put these on our standard normal distribution. So the negative 0.5 is right here, and then the 2.5 is here. So we know this is the 30.85, and then from here over is a 99.38. So we need to subtract. And you get 68.53%. Thus, 68.53% of self-employed Americans work between 37.4 and 80.6. So, conclusion would be self-employed Americans still work the standard 40-hour week or more.